Welcome, brothers. Let's get right into it. Today, I'm here to walk you through a precise, step-by-step explainer on installing and configuring the Grundfos CUE variable frequency drive for reverse osmosis system booster pumps. If you're an engineer operating ultra-pure water filtration systems, this explainer is built specifically for you. We are going to make absolutely sure your setup is safe, efficient, and dialed in perfectly.
We're going to tackle this installation methodically through 6 phases: safety and equipment, mechanical and power, control wiring, motor setup and PID, limits and testing, and finally, tuning and handover.
Section 1. Safety and equipment checks. Before we even think about touching a tool, you and I need to establish our foundational safety verifications.
Brothers, never, ever compromise on safety. High voltage is no joke. You absolutely must completely disconnect the power and apply your lockout and tagout tags to prevent any high voltage accidents. Dealing with industrial power means there's literally zero room for error before you pop open that electrical cabinet.
Okay, so let's dive into our prep phase. I need you geared up in full PPE, hard hat, safety glasses, insulated gloves, the whole shebang. Double check that your pipe filter is totally clean, but most importantly, rigorously verify that the nameplates on your VFD and your CR or CM series motor are a perfect match. Your voltage, power in kilowatts, and rated current must align exactly. And you've got to confirm that 3-phase power is stable with the proper breaker ready to go.
Section 2, mechanical and power wiring. Gears checked, manuals are read, so let's get into the physical build. We're starting with mechanical mounting and routing our main power lines.
Take your time here. Mount the drive to the panel and secure the pump to the skid. And definitely don't forget your anti-vibration mounts. You need to make absolutely sure those suction lines coming from the raw water tank and the discharge lines heading over to the RO membrane are perfectly sealed. And that pressure sensor, it's got to be installed precisely on the discharge line to give us accurate, reliable readings.
Now, a crucial mechanical requirement is spacing. When you're mounting that COU drive, you must leave a minimum of 100 millimeters of ventilation space at the top and bottom. This is non-negotiable for proper cooling. And remember, you must never mount this drive horizontally. It has to be vertical.
Let's talk power wiring. You're going to connect your main 3-phase supply directly to input terminals L1, L2, and L3. Then your output power out to the pump goes straight to terminals U, V, and W. Use your torque screwdrivers and proper cable sizes to securely lock in these connections. And hey, pay very close attention to the PE grounding wires here. You need to ground both the VFD and the motor shell directly to prevent any dangerous electrical leakage.
Section 3, control and signal wiring. Heavy power is in, so now I'll show you how to wire up the brains of the operation. To bring your 4 to 20 milliamp analog pressure sensor to life, you're going to utilize the 24-volt DC power supply coming straight off terminal 55 on the drive. This is what powers the loop that constantly feeds our vital pressure data back to the control system.
This terminal reference map is basically your best friend right now. Keep it handy because it tells you exactly where everything goes. Your shielded twisted pair wires for the pressure sensor. Those go to 53, 54, and 55. Your digital start signal connects to 18, and your emergency stop interlock wires into 19. Finally, your fault relay outputs, which report all the way back to your SCADA system, connect to terminals O1, O2, and O3. Just ensure your polarity is totally correct, and always, always use shielded cables to block out any stray interference.
Section 4, motor setup and PID configuration. Let's power up that control panel and configure the software parameters that will intelligently command our pump.
Over on the local control panel, or LCP, you'll navigate to the quick setup menu. Now, carefully punch in every specific value straight off your motor's nameplate. You need the exact kilowatts, the amps, the hertz, the RPM, and the power factor, or COS-phi. Make sure you also select the correct pump family from the menu, whether that's your CR, CM, or MG series.
Now here's a really crucial step. Once your data is all entered, you must execute the AMA function, Auto Motor Adaptation. But you have to run this while the motor is completely unloaded. This brilliant little function lets the drive perfectly learn and map the specific electrical characteristics of the stator and rotor of your exact pump, which massively optimizes the current flow.
Which brings us right into our PID configuration. Next up, you need to establish your PID constant pressure set point. Just choose the correct target in bars based on your specific RO membrane type. For most standard industrial pure water systems, you're usually looking right around 10 to 15 bars.
Set your unit to bar and ensure that your 4 to 20 milliamp feedback signal responds correctly when you manually test out the valve.
Section 5. Protection limits and testing. To protect your incredibly expensive RO membranes and ensure the sheer longevity of this pump, you and I need to establish some strict operational boundaries before we spin it up to full speed.
Let's lock these critical limits in. First, setting a minimum frequency of roughly 20 Hz is absolutely vital to prevent the pump from overheating or running dry during low flow periods. Next, match your maximum frequency to your motor rating, whether that's 50 or 60 Hz. Finally, go ahead and activate the sensor loss fault, which triggers if your signal unexpectedly drops below 4 milliamps, and set up an overpressure warning at 10% above your set point. Trust me, these limits will save your entire system from catastrophic, expensive failures.
So, when we begin our actual trial run, you're first going to use manual hand mode. We'll run it at a fixed 30 Hz just to verify the basic operation and double-check the physical rotation. Once we know we're good there, you'll switch it over to auto mode. This is where the PID controller officially takes the wheel, dynamically adjusting the frequency based on that real-time 4 to 20 milliamp feedback to maintain a perfectly constant pressure.
And brothers, please watch that pump shaft closely during your initial manual test. If the rotation is backwards, you must shut the whole thing down completely. Tag it out, confirm there is absolutely zero power, and then simply swap any two of the output phase wires, U, V, or W, right at the terminal to correct the direction.
Section 6. Tuning and final handover. We're in the home stretch now. For our final phase, we'll tune the system's responsiveness and complete our formal commissioning checklist to get this ultra-pure water unit officially online.
Switch everything to auto mode and crack open that RO valve. Now, if you notice the pressure hunting, oscillating heavily around your set point, you need to decrease your proportional gain, your K, P, and increase your integral time, your KI. On the flip side, if it's reacting really sluggishly when you manipulate the valve, carefully bump up your KP just a bit. Tweak these coefficients until you get a beautifully stable flat pressure curve right there on the display.
We are finally at the finish line. Go down this handover checklist meticulously, one by one. Verify all your physical wiring is tight. Confirm every single digital parameter perfectly matches the motor. Visually compare the electronic sensor reading on your drive to your actual physical mechanical gauge on the pipe to make sure they are totally aligned. And test those fault alarms one last time before you sign your name on the handover documents.
I'll leave you with this critical question to think about. Have you rigorously verified every single connection and parameter? Because precision today guarantees reliable ultra-pure water tomorrow. I hope this explainer gives you the total confidence to execute a perfect, safe, and highly optimized installation. Keep doing great work, brothers, and I'll catch you on the next one.